Good morning, John. Manuel. Yeah, for those who just joined, basically, we're going to start at 8 o'clock. We still have a few minutes before that. And also, you should have your microphones turned off, unless, of course, you have a long question or a long intervention, that's fine. Otherwise, we'll use the chat on the side of the... Okay. Just checking to see if there are more requests for joining in from other people. Even here. Nope. How is everybody? You can answer in the chat if you like. Sleepy? Okay. 8 o'clock. Almost 8 o'clock. Yeah, I know, quarantine time. Okay, I have somebody sending a request, so let me go and answer him or her. It came on my watch, so we go into... Okay, that's Ryan. Reply. And okay. Some of them were coming on the on Canvas, and some of them were coming on my email. So I'll have to check both of them to see if somebody's sending a request from email also. Okay. You will need this password basically for the remainder of the course. So it's the same password. Once you have it, you're going to use it. So if you would want to, you could save it on your browser if you're using a browser. Okay, more people coming. Still have a few more minutes. Let me check quickly again. No. 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 You can answer on the chat, like I said, or you can intervene to answer if you have a long question or long discussion. Did you guys do your session on lecture on Tuesday, 11 o'clock? Okay. Okay, good. Can I also ask another question related to that? And that is, where are you in lecture right now? What are you doing? Do you guys know? Which topic you're covering? Nobody knows? Oh, so you're doing quantum mechanics. So you're doing examples with the, okay, the infinite square well. Very good. So I guess this lab fits correctly then with where you are in terms of the lecture. We have 13, I mean, we have 12 people actually, so because I'm the 13th person so far. And we still have 1 minute before lecture starts. And let me check one more time to see if there are new requests for the join the session. And let me go into my email again. What's it? No. Okay. Well, good morning, everybody. And so we have 14 people. That's good. Good morning, everybody. So today is going to be a little bit short session. I just want to touch base with you guys to see where you are in terms of the lab and answer any kind of questions, especially related to from this point on, basically, in terms of the remainder of the few labs that we have left and how we're going to tackle them. And in terms of actually doing the labs and in terms of actually also submitting the labs, okay? I hope everybody is observing all the basically the rules in terms of social distancing and all of that to make sure that we're all safe. Okay. If anybody has any questions or anything else, just because we just officially started, I just want to bring your attention to the chat session that is going on the left-hand side. And please do ask there if it's a short question. If it's a long question, you can always turn on your microphone. Or a long intervention, you can always basically turn on your microphone and start talking. That way, it's probably going to be faster than having to type and wait until the whole point is basically passed. At that point, you're asking a question, which I don't see. Furthermore, once I start sharing my screen, I will not be able to see the chat. So probably it's a good idea then to just basically turn on your microphone and ask a question with the intervention. Okay. Hopefully it's clear, and I want to at least have 1 or 2 people to confirm that you guys are hearing me and you understood this thing in here. Anybody? Good. So let's talk about this lab first. And I know that we have a previous lab that we probably did not also submit yet. So if you go back into your sessions, this is actually another school. Let me go into the courses, and this is Physics 3. And this is the course that you guys come in here too. I had to make the changes. Initially, I had you guys go to Confer Zoom and join me from there, and probably some people are already there. Hopefully, they realize that nothing is happening there. Okay. Okay, somebody just requested to join us, so I'm going to stop the sharing quickly, give him the password, and then come back with you guys in here, okay? I'm going to stop the sharing, go back to that screen, and where is it? I mean, it's going to be at least this time around because these passwords are valid all the time, so there should not be any further disruptions in the future. Expect that. Okay, it's done. Since I'm here, let me check the other form. Okay, Kate also. Okay, so let me reply quickly to her also. And the link is in the message from Canvas last night. Okay, so these are two people. Let me go back to your session in here. And before I do that, I'll make sure I'm back into where I'm supposed to be. Okay, there were two people in here. One of them was requesting a password, and the other one was actually having difficulties. So I'll try to answer her quickly. Anyway, so the labs are here. And then at least all of the information that you guys are having here. I don't know if you have an updated version of the syllabus or not, but I probably will talk to Musari about this to see if we can make changes to it because the course has changed format completely. We started as a face-to-face course, which was hard enough because this course is probably the most intense course that you guys are going to have in physics, at least in this college. And then we moved to an online instruction, which is a completely different setup and different requirements for it. And it's no fault of yours and no fault of ours, so it came because it came. Now, the other problem is actually double-fold as far as the lab is concerned. And we're going to do something, we'll try to do something that is probably very hard to do, or conceptually it's not possible. Relations as much as possible and do the labs remotely and hopefully come up with some sort of an understanding of what you guys are doing in terms of lecture. Okay, so the way I do it, at least for my other classes, every time I have a new topic, I try to create let me pin this to the top. I have a new topic, I put it in here under the discussion link. And here, anybody has a question related to this lab, like for example, when the lab is due for lab 7, the answer is going to be next week. So it's going to be, what is it, April 9th. If there is any question related to lab or related to anything related to these activities, question in general, I don't understand question 7. I don't understand, for example, what is asked from this section of the lab and things like that, please post it in here. Do not send it as an individual message in the bottom in there, because I'll try to answer individual messages, but if it's something related to the entire lab, I really urge you to go into the discussion basically board and ask the question in there. Somebody else might know the answer to it and they will answer there. And somebody else might guess something and the discussion can start going, because that's how I really want my classes to be when we're doing face-to-face. I want them to be interactive. And this is basically to mimic that interaction, to make it look like at least there is some sort of discussion going on. And that's good, actually. The best part of this one is that you can always come at any time and basically intervene or ask questions or something. While you're taking your classes, whether lecture or lab, or it doesn't matter, please take notes, because something you might not think about it immediately, you might think about it later on, or while something is being talked about, you may have a question there and there, but while you're taking notes, you're probably going to put a circle around it or put the note on it, and later on you can come back to it. Taking notes is essential as far as learning, so please do that, okay? In terms of labs, let's go back into the tabs for the assignments. That's where the labs are at. And that's where all of your labs are. And I see that some of the homework actually they are also posted there as assignments. And lab 6, I don't know if we collected lab 6 or not. Can somebody answer that quickly? Because I don't have, like I said, the chat going on. Let me see if I can access it from here. I don't have anything in the chat. Let me get the chat. I don't think we collected lab 6. Yes?
I think we did.
We did do lab 6, but
yeah, we did.
Did you submit it? Because I think it's probably if you submitted it still somewhere in the, oh, you guys submitted it to your instructor, to Musawi. So I have to go back to campus and pick it up from the place that was left for me. Okay. Okay. If you did, then that's fine. I will have to collect it and grade it for you guys. Lab 7 is here. Okay. So lab 7 is really one of the few labs that are actually can be done anywhere. You don't have to be on campus to do it together. Okay. And that's something that one of you guys asked. Basically, is there a requirement for this session? Yes, I understand it's not, because this lab actually can be done at home. But I really want to leverage the features that are available on Canvas in terms of discussions. That's why I want you guys to also start working together, even though you're remotely located, but have that discussion. It has an extensive instructions in here into how you're going to do this. Did anybody have difficulty with that zip file?
No, it was good.
Okay. Make sure that they have, if anybody had any difficulty with it, let's go to the chat. Nobody? Very good. So that's what the key for this lab in terms of data collection. Had you have been on campus, you would have to have that. The trouble with that file, it was written in an old version of Visual Basic. So I don't have the code right now, but at some point I'm going to recompile that file using a newer programming language and compile it probably on different platforms, so that you guys, if you have a Mac, you don't have to worry about it. You can run it still. So at this point, we have to live with that limitation and the fact that this was compiled on a Windows machine, so you have to really have access to a Windows machine to do it. So that's basically one thing for this lab, and everything else is almost self-explanatory. And I showed even with an image what to do, and you did it in Excel file, and the Excel file I made sure that it's actually located in the same folder so that the program will access it and give you all the different simulations for running the different die. And basically, if you did it in the lab and you tried to run how much, 30,000 or 20,000 times, or even a 6-phase dice, it's going to take forever. That's the advantage of that lab, to have it do it there, because you click on just one button, it turns it several times for you, using a random function behind the scene with different seeds each time to give you a true, or at least as close as possible from a random effect, so that you will have random data basically, depending on how many basically faces you have and things like that. Okay, so that I hope was clear and understood, and I was trying to be very clear in here for you guys to really try to generate as much as possible random data. Do not put them consecutively, because that might confuse the seed, and you might be seeding the same basically set of data, and then you probably start to see a pattern, and that's because it's not really random. Okay, so I want you guys to really come up with some basically non-sequential numbers that are not obvious and numbers that are not similar, so that at least you see that there is a true, or at least try to mimic as much as possible a random effect, so that you guys have random data. Okay, and the lab now is a file upload. We are not going to be collecting any printed labs, so if you're done with it, you're going to be sending that lab into on Canvas. When you come back, when you're done with the assignment, you come back to your lab. It can be one, it can be many files. It can be one format or a combination of different formats. The lab report itself is a fillable file. What do I mean by that? Let me try to pull it first. And we're going to talk a little bit about the lab. What is the file that I have in here? Yeah. So let me stop sharing that screen and share with you the fillable file. But I just make sure that it's clear to everybody how this is going to operate. So let me share the PDF file now. Okay, so what you're looking at right now is a PDF file. At least I need somebody to confirm that, because what happened in one of the sessions, I was talking and talking. After 4 or 5 minutes, I discovered that the file was not visible. I was talking about it to myself, basically. Can anybody confirm that you can see the PDF file? Okay, very good.
See it.
Very good. So if one person can see it, I assume everybody else does. Okay, very good. So this is a PDF file. Right now, I did not put any kind of a JavaScript behind the screen to make any kind of requirements, but down the road, at least the next PDF file will have at least some sort of a structure in it. There will be fields that are required and fields that basically have the option to skip getting a 0 in them. So I don't, at least I need the name right now. That is a requirement, because I cannot grade something and then at the end, I don't know whose name it is. So there are some fields that will be required, and also there are some fields that will be basically marked as the numbers with a certain sig fix basically in them, and so on and so forth. So there will be some sort of logic in this one, in the next version for the lab report. This one is as simple as it gets. With the numbers that are going to be, with the fields that are going to be required, you are going to have a trouble if you don't fill them. So basically, if you forget to put the name and you fill everything, and you spend about 2-3 hours working and getting the data from here and there and putting them, especially if you are not recording somewhere else the data, and then you say save, nothing is going to be saved. You have to start all over. So the required fields, is a good idea to always start with them, and that's what I will be doing next time, is the name, the opening paragraph, the conclusion. They are going to be a must. So you at least have to put some stuff in them before you move on. So that is something that I will be doing. And then that's one thing. And then there are some other data, for example, once they are formatted, and let's say, for example, you're asked to put a number in there and you try to put text, it will reject. It's going to ignore what you're typing and wait for you to put numbers. So that's basically how this thing works. Now, it is of the utmost importance, and I cannot emphasize that enough, okay? And I have seen this, no matter how many times I say it, it's always, there's 1 or 2 people who forget that, and at the end, they don't do what I tell them to do. And this is very, very important. Do not use any browser, and I know to fill this file on the chat session, and here I put it all in caps. Some of you probably take offense to that because they think that I'm screening, and that's probably because actually I am. Okay? So it is very important. Do not use any browser, okay? Whether it's Internet Explorer, whether it's what is the other one? Microsoft. What is that thing? Microsoft Edge, or Chrome, or what is that? Safari, or Firefox. From all of them, the ones I tried, the one that really prompted me up front and told me do not use me was Firefox. If you open a PDF with a fillable fields in it, Firefox will warn you that this file contains a form file, and Firefox does not handle this type of file. So, but Chrome, what it does, Chrome for you, is basically it's going to start, it doesn't do anything. It allows you to start filling it, and you spend a lot of time filling this file, and at the end, you're submitting the file. You say, okay, I did everything that the instructor asked me to do. I'm going to upload it to Canvas, and it's going to come exactly clean as I have it right now. Blank, nothing in it. So that's a waste. So you have instead to use Adobe Reader or dedicated programming software for that, okay, that handle it. One of the advantages of Adobe Reader is this feature in here. I don't know if you guys can see it or not. It's the highlight existing fields. If I remove it, I mean, right now the cursor is is flashing somewhere because I put the mouse somewhere. Right now, when I move it, it's not flashing anywhere. And there is a line in here, but it doesn't show me that there is a field in there I can fill. But I can see a line where I can put my name in here. And if I hover over it, it's going to tell me what that field is. And here, there is another field in here. And if I hover over it with the mouse, it's going to tell me what that is. That's goal and objective. So, but if I turn on this feature in here, it's going to show me visually what is going on start with, okay? Especially for tables, that is very, very important. So that's another benefit of using an Adobe Reader. For any other browser, they don't do that. They just basically give you a form. Probably they will advance in the future so that they will be able to handle this type of files, but at this point, don't count on them. There is a fundamental reason why that is so, and that is because the internet fundamentally is what is called, they call it stateless, basically. You don't save anything in it. But for this one in here, it saves because it saves on your computer. So once you're done with this file, save it on your desktop to make sure that you have a version of everything in it. Open it again after you save it. Make sure you can read things in it, the stuff that you read, your name, the answers to the questions and all of that. And one of the nice features about this one in here is that what is today's lab today is trying to learn, quantum mechanics, aspects in terms, so you don't have to use my verbs, okay? Of probability, so I'm just being a little bit, I forgot how to spell probability. Is it probability? Is it like this? You see, the nice feature about this thing in here, it has it's a rich text format. So now I know how to spell probability. This is actually not correct. Actually, this is what it's suggesting I should use. Okay, so I fixed it. You understand in here what I'm trying to say in here? This is actually a very nice feature. Instead of having to worry about the spelling and worry about stuff, I can put things in here as if I'm working actually on a Microsoft Word. So this is actually a very nice thing in here, and now I know how to set probability. You guys see that?
Is Adobe Reader free?
Adobe Reader is 100% free. I would not recommend anything in here. So the Reader is free, and the trouble with it now is that it's a good idea to download it from Adobe's website. Okay, so you have to go to Adobe's website and try to download it from there. So let me see if I have the session going in here. Okay, where is Adobe Reader? So let me get the Adobe link for the Adobe Reader. Adobe Reader. The reason why this is important is because I don't want you guys to go and download the Adobe Reader from another location other than Adobe itself, because you might get with a different version of somebody else's Adobe, and that is not good. Okay, so the link is on the chat right now, and it doesn't matter what platform it is. You can skip those special offers they ask you to install McAfee. I never do that. That's actually not a good software at all. Very lousy one. So don't do that, and they will ask you at some point to download probably Chrome. So they want to sell stuff to you to make sure that you're getting your Adobe stuff in here to really do your thing. And of course, it's up to you. If you really like the other products, you might want to download them. Don't go to some other third party and download stuff unless you really trust those things. One of the places I usually trust, and actually I check also nonetheless, is the site CNET. Because you might be downloading something and you get a virus with it, or you corrupt your computer, and that's not good. Especially with this free stuff, people get basically the basic things of it, and they add code to it, and they bundle stuff with it, and they try to sell you some nonsense, other things, or infect your computer, or use it as a zombie computer to do other things with it. Anyway, the link is there for the reader. Get it. It's much easier to work with it and to save the file with it. So let me go back into what I was, because I know, guys, you're still seeing the probably PDF file which we shared with you guys. But hopefully the link is on the chat in the bottom in there. And if need be, I'm going to send you the link also. Down the road, we might need something else too. So you might need to consider that too for our simulation. So on the chat, I'm going to give you another link in here. And you might need to, if you can download this software, actually it's a very good software for doing all kinds of calculations. It's called Geogebra. We're going to use that for simulating some of our labs. And for the lab, for specific labs, after I upload the file there to GeoGebra, I'm going to upload it to my personal account. And once it's uploaded to my personal account, I want you guys to also go and grab that file from there. If you can, first of all, it can work on the browser. GeoGebra can work on the browser, or your own browser. And I'll probably show you down the road later on when we're doing that part, how it looks like. And sometimes it's very slow, though, especially when we're doing simulations, and simulations involve a lot of calculations, and it becomes extremely slow, no matter how good your internet is. So if you can download GeoGebra, and it's free also, 100%, download it and copy the file to your desktop and start working from your desktop and doing the simulation from your desktop. So that's something else that we will need down the road. And again, this is make sure you go to their website and you can sign in and create your own basically stuff, and you can upload your things. And once you're done with your animation and answer all the questions, you can save that for your own purpose use if you want to. It's a very powerful platform. I mean, it's not really great, like for example, MATLAB or something, but at least it does a lot of things for us. So we can use that. And you can actually solve differential equations using that. If anybody is taking a DTQ, that's actually a very good thing to do. So anyway, so those are some of the free tools. The bottom line is, do not use any browser for this fillable file, because you're going to run into problems. So don't do that. And I know, and I did that actually with some of my other classes that I used to teach online, and that was years back. And no matter how emphasized on it, there is always one or two people who basically forget to do that step, and at the end they are frustrated because they are uploading an empty file and they get no grade for their efforts, and that's problematic. So I want to emphasize that again and again with you guys. And if you're into some problems, please let me know, and I will be more than happy to work out those things with you guys. If need be, just you can actually come to Zoom and we can show me your screen and share with me your screen, and we will see exactly what went wrong. Okay, at least to help you remotely to see what went wrong. Okay, so now we're filling this slab. Any questions so far about this tool or any other tool? No?
No, I'm good.
Okay, very good. So now you come in and again to this section, and it's actually required. Every section in here, you're going to be required to put data in it, to put numbers in it. Right now, if I put any nonsense in here, for example, okay, this is a good thing in here. Try to come in here to this part in here and put 5, for example. It takes 5. And if I come in here and put, let's say, for example, 5, the word 5, F, F. I'm trying to write F-I-V-E, but nothing is happening in here. The only thing I was able to do is delete that thing there. So this is a good thing to know, to see how actually this file has a little bit of logic in it. And the input in here, it's requiring a number, and that number has to be a specific number. So if I write 5.5, it's rounding it for me, okay? So it knows that 5.5. How about 5.4? Okay, so it's rounding it down. So this is supposed to be a whole number, okay? So this part in here, that's why it's doing that for you. It's not supposed to be a decimal number, okay? I can actually put the requirement later on if you want to, so that if you put by mistake, for example, 5.2, it's going to tell you that this is a problem, but I didn't do that. It's actually doing the rounding for you, okay? Because this whole thing is going to be whole numbers for this particular lab. It's not always. Here is a percentage error. So if I put 1, this is 100%. Oh, I didn't need to put 100%. I meant actually 0.01. So now it's reading 1%. You guys see this thing in here? So if I want really a 2.3% after I did the calculation, and I'm thinking it's 2.3, that is going to be 250% error, which is a huge error. So actually, I want to write it 0.023. Do you guys see the difference?
Mm-hmm.
So please pay attention to this part in here when you're filling your numbers in here. This is again, it's going to be a whole number. So it's 5.4. What is this one? Oh, actually the simulations. Oh, this is a calculation. This is supposed to be a decimal point in here, because it's this calculations in here. Since we divide by 2, now it's going to be a decimal point. Okay. So again, this averages, the square root is going to be a number that is actually decimal with a decimal point in it. Okay. I don't mean to save this file at the end of the day. That's the advantage actually of doing it this way. If you don't do anything, it should be. So, you're done with the full file. Now, sometimes you have to do a graph. You can use Excel if you have access to Excel, and Excel is a free software also, okay? For students, I know if you're not a student, you have to pay for it, but students usually get the entire Office suite from Microsoft. If you sign in with your student's name, you should get Office 365 that includes Excel. Now, if you don't have access to Excel for some reason or the other, you can go to the Open Office. From their website, again, openoffice.org, and it's actually free software. They have something called Arc, and that is actually also graphing tool. It looks exactly like Excel. As a matter of fact, you can open an Excel file with OpenCast, and you can save it back into Excel. So that really works both ways. So you can still do that. In other words, when you're asked to do a graph, you can still do a graph, and it should not be a problem. OpenCast can do it. I know some people, they have access to also the Google Docs, the Google software. So again, if you don't have any of that, you can still do that online. But at the end, we need the graph, okay? So once you have the graph, you can take a picture of it. You can take it, you can send it to me as a graph from Excel. You can attach it as a graph with your basically image, whatever format that you guys feel comfortable with. I rather prefer PDF file as number one, honestly. PDF file ensures the format does not alter, does not change. Because if you take a file and you work with it probably with Google Documents, and then you change it to Excel or you change it to OpenCalc, the graph and the format might change. The colors might not transfer, the shading might not transfer, even sometimes the form, the way the curve looks like, it probably will be maybe compressed because the scale of the x-axis does not transfer or something like that, and you may have a problem. But if you take something like this and convert it into a PDF file, it should look exactly how you have it. For that purpose, you have to have something to make PDF files for you. Qt PDF works. Qt PDF is a free software, and this is something you really have to download somewhere from a trusted place like CNET, for example. I know there is another one called PDF Creator, I think, PDF Creator. This is a shaky thing. Both of them are actually, both PDF Creator, and you have to really know that you're from a trusted source. I'm putting in here CNET. I'm not associated with CNET whatsoever, but I know at least most of the time they have their downloads rated, and people can look at the rating and make sure that you know what your download is safe or not. Because what happened to Qt PDF and PDF Creator, they have actually the same kernel, and people modified them down one way or the other, and they come up with different versions. So if you go to Google and start looking for Qt PDF or PDF Creator or something like that, you might end up with a link that is kind of shady, and that's actually not the exact software. And at the end, it will probably do what you want it to do, but at the end, it may not look good. I take PDF. If you can't do PDF, do any other format. If you have a newer version of Windows, like Windows 10 or something new, I think Windows came up with something called Print to PDF as a default, as one of the printers that are accessible to you on the computer. That too works. But the bottom line is PDF is actually the best way to go. So when you're asked to do a graph, please do it. And if you can convert it to PDF without any trouble, please do so. If there is a trouble, you can take a picture of it with your, there is a print screen, and you can send it as an image using your good Paint, or you can take a picture with your phone, actually, or with your camera and send it. So at the end of the day, do that, please. If you can send it actually in Excel, send it in Excel too. I can handle any kind of like that one, like I said, but the preferred way, like I said at the beginning, is PDF. The next thing in here, of course, it will not apply to graph with text format or Word format or Excel or any other format is fine for me, okay? We're clear on that? But you need your stuff to be downloaded in terms of uploaded as a file. Anybody familiar, and I want this is everybody, anybody familiar with this last software that I typed in there?
Latex, yeah.
If you are, then send that. Okay, send it. This is actually the most powerful thing. So if you know how to do graphing with latex, do that, okay? So any kind of typesetting, because the entire report can be written much cleaner with latex, okay? Do that, okay? So that's actually, if you're not familiar with it, this is a time when you guys start to get familiar with it, because pretty soon you'll be writing theses, and this software is actually a very powerful thing for all kinds of writing, at least math and graphics and things like that. This is a very powerful thing. That's most of the people how they wrote their PhDs, at least in the old days. I don't know. Nowadays, probably people are lazy and not learning much, using words and other stuff. Okay, so we have 3 people who are not here right now, and we're gonna share this recording on YouTube, and I'm gonna send you guys a link to my account so that you're basically for those who are not with us, so that they can see basically what's going on in here, okay, so they see what was done, and for you actually to come back and later on look at the notes and things. Now, done with the report, included your PDF file, and you did everything. Some of these things probably you cannot do it in, like for example, with question 6, I was looking at it earlier. Verify that equation 16 are correct. What is equation 16? Equation 16 is a bunch of equations. You cannot do them in this, what is it, 3-4 lines. So you really have to attach something. Either you write it in Word or LaTeX, or you write it in by hand, and then you're going to submit it as a I changed PDF files. Do you guys see the PDF file that is changed, or it's still the same one?
Looks like it's still the same one.
Okay, so I'm going to stop sharing that PDF file and go back to the lab instructions. Before I do that, let me take a snapshot of what we have in here. Everybody who's here. We have 19 people. I know probably one person is not here right now. And Kate was able to, at the end, join us. Okay. Okay, so this takes care of the attendance. Let me go into the other PDF in here, the one that has the instructions in it. Okay, so this is the one that you guys have, and hopefully, guys, you went through this one. What is question 6? Here's question 6. Verify equations 16 are correct. This is 1. This is okay. 3 equations, they cannot fit in that gap in there. So what you do in this case, you really have to attach something else to show that. Did you do this in class already? Anybody? Did you do this already in lecture or not yet?
We have discussed, we briefly discussed it.
Yeah. Okay. This is important. This is basically the what is that? The Gaussian distribution. This is because we're dealing with probability in this case for harmonic oscillator, and this is a solution for it. And you're supposed to, and there is actually in here at some point it shows you. And this lab is referring a lot to Schaum's mathematical handbook. I don't know if you guys have access to that or not. It's just a very good, useful document to have around. You cannot, I mean, physicists, they say basically, you cannot catch a physicist without his integral tables. This is one of them. Okay? This is a useful one. But of course, you can only do so much. You can carry only so much with you. There are some simple ones like the Gaussian distribution in here. This know how to do that, okay? And basically, to normalize this distribution, what you're saying in here is that the probability of finding, for example, the particle or the harmonic oscillator somewhere in space has to be 1. So the integral from negative infinity to positive infinity of this probability distribution function has to be 1. From there, you're going to require this integral to be 1, and from here, you're going to find the value for A related to beta in here, and beta is actually related to the properties of the harmonic oscillator as such. So that's how you find that expression. And you're going to also find the average x. In this case is going to be 0. All you have to do is plug in the x, and this is being an even function. When you multiply it by an odd function in here, namely x, so when you integrate from negative infinity to positive infinity, there will be a positive contribution from the positive side and the negative contribution from the negative side, and both of them are symmetrical, except one of them is positive and the other one is negative. So it's going to be 0, okay? The probability of x squared is not going to be 0 because if x was negative on one side and positive on the other side, but both of them, when you square it, they're going to be positive. So there is definitely a value in here. And when you find this expression here for the square root of, for delta x, which is related to the difference between x squared minus the square of x, and square of x is actually 0 in this case. Where is that? We're going to find where is the definitions, because you need those definitions, okay? Without them, you will have difficulty. Did anybody do this part yet or not yet? Or am I, so here is the delta x. This part is 0, so delta x at the end will be just the square root of x squared. The average of x squared, I should say. That's how you find the in there. What is question 16 in here? So this part is 0. So delta x will turn out to be just the square root of that number, which is exactly what this thing is saying. Did everybody do this part of the lab or not yet?
Not yet.
Okay. So this is the proof for this is actually here somewhere, but there is an error actually already, and I want to point your attention to this, especially to this. There was an error in it, and I want you to make sure you correct that on your end. I didn't have time to go back into the instructions and fix that, but it's somewhere in here. When we're doing this Gaussian integral, we come up with some nonsense number. I mean, it's very easy to see that it's in something wrong. Okay, I think I probably skipped it or what? Is this a different instruction? Okay, it would be okay. I know there's an error in this line. I want you guys to fix that error in it too. Okay. Okay, if I can't see it now, what I will do is, actually I don't see this thing. Oh, this is part of the appendix. It's part of the appendix, I'm sorry. Okay, this is basically for the Gaussian integral. Okay, what this is saying is basically is that the integral, this is this expression we're trying to find. This is actually the probability itself, you want to make it equal to 1. That's basically what the whole thing is saying. And we want at some point to find this integral in it. You guys want to do this together in here, since we have time still?
Sure.
Yes? Okay, let's work on this in here because it's important, and you will see that where the error is. Actually, the error is, let me go back into PDF file quickly. I know that you're looking at it. The error is actually here, okay? You need to fix this part of your lab report. This is wrong, okay? 1 minus R, this has a minus in it somewhere. So this is actually wrong in there, okay? So there is not 1 minus R over something. So let's do this in here. Let me go back into stop sharing that screen. And let's share with you another screen so that we can work together on this. Okay, so this is OneNote. This is part of the Microsoft Suite in here. And at some point, we want to find the probability function basically as we defined it as P of X basically dx is equal to, let me go back into PDF file to make sure that it's written the way that you guys have it there. It's part of the appendix. That's what the error was, okay? So trying to help, but in doing so, it did not really do it correctly, okay? So p of x dx was a squared exponential of minus beta squared x squared dx, and from there, you're supposed to find everything in there. So let me go in here. So it's going to have an a squared, and then exponential of minus beta squared x squared dx. The normalization requires what is the value of a. Normalization here means that this sum of this probability from negative infinity to positive infinity must be equal to 1. That's what it means, that we are 100% sure that the proton, or I'm sorry, the oscillator in this case exists anywhere in space. That's what this means. Okay? So we are 100% positive that it's somewhere in there. From here, we're going to find what the value of a needs to be. Okay, so let me move on this screen out of my way and extend this region. So what we're saying in here is this integral, which I'm going to call I in here, is equal to the integral from negative infinity to positive infinity of, I'm going to leave it the whole thing, a squared with an exponential of minus beta squared x squared dx must be equal to 1. If at the end, this must be 1. So basically, that's what the requirement is. From here, we're going to find the condition for A, and that's the first equation, and probably the most critical equation when you're doing when you're answering this question set. But after that, all of the rest of the questions follow through quickly. So this is the Gaussian distribution. That's probably you're going to do in lecture, so probably you're saving some time for you guys for lecture. So what you say in this case is this integral, because the integrand, we use a different word for it in here. The x in here, after you integrate, disappears. Do you guys see that? That you're integrating from x, a function. At the end of the day, that variable will disappear after the integration. That's from the fundamentals of Calc 1 or Calc 2, I guess, when you guys start doing integrals. So x in this case is so-called dummy variable. You can change it however you want to, and the integral doesn't change. So what I'm going to do in this case is, I'm having difficulty writing with on the screen in here because we don't have access to whiteboard. So this is probably better. What I'm going to say in here, the same integral, I can write it as the integral from negative infinity to positive infinity of a squared exponential of minus beta squared. Pick any number in here, any variable, I'm sorry. I'm going to call it y squared dy. So did I put in here x? Yeah. So as long as you can put any you like in there, so it should be the same, because again, after you're done with the integration, the number is the same. So instead of doing that, what I'm going to do in here, I'm going to calculate I squared, and you will see why there is a better way of doing it this way. Now I squared will be just the product of this I and that I. Is correct? That's basically what I squared is. But make sure you change the variable. Don't keep the same variable, because you'll be tempted at some point, if you keep the same variable x, thinking that, hey, first of all, I have a dx times dx is going to be dx squared, and it doesn't make sense at all. And the other thing also is exponential of minus beta x squared times exponential of minus beta x squared, and that is exponential of minus 2 beta squared x squared. But the variable itself is meaningless in this case, at this point inside the integral. It's just any variable will do. That's why we have to change its name to make sure that this integral is, actually there are two integrals, not just one in this case, when you square it. And both integrals go from negative infinity to positive infinity. And one of them is with respect to some dummy variable we call it x, and the other one we call it y. And now I have a to the power 4 because I squared everything. That a has nothing to do with the x or the y. Exponential minus beta squared times the sum now of x squared and y squared. So this is what you do when you square actually integral. You have to make sure the variables don't collide with one another. Since they are any variable you like, change their names, and you're going to be fine. Okay. But now, if I do the following transformation, and I think it's part of the of your notes in there, the appendix there, in such a way that x is some variable r cosine theta. In other words, I'm doing change of variable from x and y to new variables x and I mean r and theta in such a way to sweep. So the early integral was over x from negative infinity to positive infinity. And now the new integral and the other variable is from negative infinity to positive infinity. And I choose them in such a way that they're, because any two will do, so I choose them to form some sort of a Cartesian coordinate system. So what this integration over x and y is really doing is getting me the entire plane. I go from negative infinity to positive infinity for the x-axis. Independently also, I go from negative infinity to positive infinity for y. What I'm doing this integral is actually the entire plane that is formed by these two coordinate systems, x and y. I could do the same thing by requiring theta to go from 0 to 2 pi, and having r goes from 0 to infinity. So the r variable in here, which is just the projection of this vector in the x and y direction, will do the same thing for me. Because if r goes from from 0 to infinity, and theta goes from -1 to +1, because theta is very so to sweep the entire area in here, so that means I have the entire plane. So this transformation of variable will do the same thing for me. And now, using the polar coordinates instead of the Cartesian coordinate system, dx dy, namely the area in here, element of area, is going to be actually in polar coordinates r d theta dr. Okay, that's something that you actually should have seen, or actually in physics 1. So basically, this is where the r vector is. It can change in magnitude by an amount dr, and it can change in direction also, since the direction has changed by d theta, and a displacement which is now r d theta. So this is the area, element area, now expressed in terms of polar coordinates. And x squared plus r squared is simply equal to r squared. So that's actually another thing. So when you square these two and add them together, it's going to be r squared. So doing that transformation, the integral then becomes, that is the square of I, which is going to be 1 at the end of the day because of the normalization requirement. So I squared, which has a to the power 4, times the integral, theta changes from 0 to 2 pi for d theta, and r changes from 0 to infinity. Now I have r dr times exponential theta. And it is this integral in the appendix that is really not working well for me. And let me first of all make a new change of variable. What I'm going to call in here is, first of all, this part of the integral, because these two integrals are independent of one another, this has no theta in it, so this is just going to give me 2 pi. Okay, so that part is easy in here. So it's going to be the square of that integral is going to be 2a squared pi the integral from 0 to infinity of r dr exponential of minus beta squared r squared. Once you have that, of course, if you guys want to, I can share these notes with you guys at the end to make sure you're following the arguments in here for this. So once you have that, then you're going to make another change of variable. You're going to call r squared to be just u, which means that r dr times 2 is just du. And once you do that, then this integral should be easy to find at the end. So the integral at the end should be I squared, that is still. This 2 will be consumed in the RDR because 2 RDR becomes du. So I'm going to remove that 2 from there and move it all the way to the integrand. So I'm left with a squared. Was it a squared? Yeah, a squared. I'm sorry, a to the power 4. Yeah, a to the power 4, not a squared. So, okay, for some reason my pointing is not working. Yeah, okay, a to the power 4 in here. So a to the power 4 pi. Remember the 2 is gone now, and it became just part of the u. And so this whole thing, 2 RDR is just du. And u now changes from 0 to infinity. So the boundaries of integration do not change when I do this change of variable exponential of minus beta squared u. And this is just an exponential now. And integrating an exponential is just an exponential, except you have to divide by the argument of the of the variable in the exponential. So I squared at the end is simply equal to minus a to the power 4 pi over beta squared times the exponential of minus beta squared u evaluated between 0 and infinity. This is what the mistake is in the appendix. It's this last part. In here, this at infinity is going to be exponential of minus beta squared times infinity, if you like. It's actually a limit. You cannot make it equal to. So this is a limit minus the exponential of minus beta squared times 0. This is going to be 0, and this is going to be 1. So you have 0 minus 1, which is 1, times a negative number. So it's going to be negative 1 times positive 1. So the actual integral is a positive, because the negative and negative cancel. A to the power 4 pi over beta squared. Okay? So all that is left to it. So that fixes that mistake in there. We're requiring this thing to be 1. Because we're saying in here is that somehow we're going to find our system somewhere in space. Of course, when you square the 1, it's going to be still 1. From here, I'm going to take the square root and then the square root one more time to find that A is equal to the square root of beta divided by pi to the 1/4 power. And it's exactly what we were asked to do from the notes. So if I go back into, I'm going to stop sharing that file in there. I'm going to go back into the PDF file in here. This is what we are supposed to do. It's to show that A is the square root of beta divided by pi to the power 1/4. So that's part 1. For the second part, you really don't need to do much integration. All you have to say is that because this is an art, when basically what you do in here, you multiply this by x, and this whole thing is squared, of course. And so you're going to put an x in here and you integrate. This does not change with x. I mean, when you change x from negative to positive, because it's an even function, but x itself changes. So instead of having a curve that is some sort of, it's going to be negative in the bottom, and the negative region, and it's going to be positive in the positive region, and both of them are equal in magnitude. So the two areas cancel, and now you have a 0 integral. So this part is easy. All you have to do is argue the symmetry. There is actually a theorem in calculus that says that basically for an odd function under the integrand and the boundaries of integration are symmetrical. It's negative infinity, positive infinity. So the integral itself is 0. So you can make that argument. And here it requires some honest work. You don't need that computational work at all. All you need is just to do oh, I'm sorry. This one actually requires some work too. You have to do an integration by parts first. And then you're back to the same situation where we started from, to here, to part A. So there is a two-step process for this third equation, okay? The first step is an integration by parts, and then brings you back to where you started with that long calculation for this probability. And that you know what the answer to. It's going to be a 1 at the end of the day. So that's going to be at the end. For delta x, the last part is just plugging these two numbers. One of them is 0. The average of x is 0, so it's going to be minus 0 squared. And this is going to be just this number. So at the end, delta x will be just square root of this whole thing minus 0. And that is square root of this thing. So in other words, there is some honest work that you guys have to do, calculations I should say. And I know you're doing this part of your lecture, but again, the lab is trying to connect back to your lecture to make sure that you have a full understanding of this thing. Okay? Questions?
No, that was good.
Okay, everybody, if you have any questions, please do not hesitate. I know a few of you came in late. I'm going to stop sharing this file quickly here, and I'm going to go back into the share my Firefox. Where is Firefox? No, that's not it. Here. Share. Let me go to this form in here. By the way, if I want to go back, I don't know if you. This is the link that takes you to that Adobe Reader. So if you want to, you can uncheck these optional products. If you want them, fine. If not, you can uncheck them. And there is actually a trial version which I never do because after 30 days or something, they will ask you to pay for it. so I just want to continue and install the reader, that's it, okay? Although I think Adobe is offering this version of their full version of Acrobat for free, at least for a certain period of time, to allow students to do their work. So you need to check on that, okay? So see if you really need, you don't need it for this purpose at all. Honestly, all you need is just the reader, okay? So let's go back into the lab in here, and please do, if you have any questions, come in here to the discussion. I think somebody has already posted a question under last session, so you come in here, section for the lab, and Miguel asked the question. I answered, and Kate, now I answer, it's working, isn't it? Because I see you joined us, okay? Kate, again, you can put on the chat, if you check in here. Yes, okay, so that was her answer. So she asked the question in here, and please, if there is anything in here related to this lab in general, related to this difficulty, for example, running through some of question 7, question 6, question whatever, please do ask it in there. And if somebody else wants to intervene, please do so. Do not wait for me to say anything, okay? You just go ahead and intervene and work together on this thing, okay?
Okay.
So this was just an overview, basically, of how this thing is working. I know the next labs are going to be a little bit more involved. So when you come in, please watch the announcements that I'm making in here. And also, after we're done with this session, I'm going to come back into this section in here and add the recording of this video that we did together today, and start it from 8 o'clock until whatever we stop. Put it in here too. And so that if somebody wants to have access to it, I'll put the announcement again in here. I have been uploading a lot of videos for other classes on my YouTube account, and I was requiring, I'm not requiring, I was asking my students to follow those YouTubes. What do you call it? The word for it for YouTube. Anyway, there is a word for it. I think I lost it right now. So that you can get notified immediately when there is a video uploaded. So instead of me waiting for me to come and tell you, hey, we have uploaded a new video, please go and watch it if you have any questions. And I will be doing that for the instructions from now on for the lab. I'd rather have you guys get it immediately once it's uploaded. That way save time, because it's not my convenience, but rather it's your convenience. So if you have time later on to do it at your own convenience, not mine, but hopefully do it before the due date, okay? So that's basically what I'm asking. Subscribe, yeah, the word is called subscribe, okay? Subscribe to the channel, so please do that once you receive the notifications. That way, if there is a new video, you can ignore it if it's not related to your class, but if it's related to your class, it's a good idea. If you have time, that you can go and start working on your lab instead of waiting for me to go and make the announcement, hey, the video has been uploaded. Okay. So, any general questions related to this lab or any other thing related to the entire thing that we're doing so
Not at the moment.
far? Okay. Anybody else? You guys use the chat. Okay, you don't have to. And like I said, for the people who came in late, you can turn off your microphone unless you guys have questions, but I'd like to have some feedback sometimes, because I really don't want it to be a one-way thing. So usually my instructions are, I want them to be actually two-way out things. Actually, I like it very much when students actually do a lot of things. And that's the way it works. That's the way it should work. And just because we moved online should not really prevent us from doing that. Question from Joseph is asking, are we going to be every Thursday unless otherwise told so? Yes. So the answer to that is absolutely yes. We are going to be here every Thursday unless I tell you guys that we're not meeting for some reason or the other. I know we only have a handful of labs left, and we're required to have a certain minimum before we call it basically a MET requirement. So, and I scheduled all the labs until the end of the semester. So I'd like you to be present in there. Granted that some of you probably now, because of the work schedule, you might be asked to work different schedules. and I will be uploading these things. But the sooner you are joined in, the live you have the question, the better it's going to look like, and the more basically enriched the topic is. And that way I hopefully answer any confusion that you guys have. We might like, okay, this is not possible to do, for example, at home. So we're going to skip that part and we do just this part. So you're aware of what's going on in terms of every specific lab. So yes, we're going to be meeting in here every Thursday, unless we are not able to do that. Okay, somebody is complaining about the speaker. This is not really the speaker. I don't know, and you can tell me that if it's true or not. Is the sound sometimes lagging? Yes or no? Yeah, and that is because of the internet. I think the internet sometimes is kind of slow. So if you feel like there is a part that went very fast and was not clear, please do ask to say, okay, that part was kind of went too fast and we didn't catch it. It's the internet that is a problem, not the speaker or the microphone. Okay. So I apologize for that, and that's one of the limitations we're running into. Okay. If there isn't any other question, and I trust this lab was extensively, explained, and hopefully you had no difficulty with that file, because that was really the thing that was bugging me, is that file that was required to run on your machine. The good part about it is that it's not an install, so it's really a standalone. It can operate even without administrative things. Although Microsoft now prevents you from running anything, it always asks for higher level things just for security things. But since it's working and I see that nobody's complaining about that, then that's good. And this lab is good to work. If not, this is the plan. If there is something that I'm going to be doing demos with, I'm going to be demonstrating things and sharing with you the data. Okay. That's what the purpose of Geogebra is, and that's what the purpose of me. Actually, I went and bought a kit from eBay the other day that include not the capstone, includes the other one, vernier equipment, basically just to do the demos in my home and share with you guys data. So that's basically the whole thing that we can do at this point. Hopefully, you guys can have at least something, learning experience from this whole thing. If there is any other questions, then we probably are good to go. No?
Not at the moment.
Okay, you guys have a nice end of the day. Basically, continue working on your things. If you have to think of something, please do not hesitate to come back into the session in here and ask the questions. And do not share the password with anybody. What happened the other day at one of our sessions, we did not have it locked in with a password actually. And I would assume that somebody shared the link on some of those forums, basically with a Facebook or one of Instagram or something like that. And we ended up with unwanted audience, and things was a little bit confusing. So from that point on, I basically made it into I sent you guys the password. Did anybody log in without a password? So we'd have to type in this thing in here. Or probably they joined from the other link, which I'm going to remove from Canvas.
Yeah, I joined from the other link. I didn't need a password to get
in. Okay, so I'm gonna remove that link from there so that you guys have to use the password.
Okay.
Okay, guys. Thank you. Have a good rest of the day.
You as well.
Be safe.
Bye.
Thank you.